In Activity 6, Building an Electromagnet, students extend what they have learned about magnetism and electromagnetic fields and build an electromagnet that can pick up objects. They then alter one variable at a time to determine the relative strength of an electromagnet, and finally record and graph data obtained from their experiments with electromagnetism. You will need the following materials from the kit: Activity Sheet 6, Parts A through C, D-cell batteries, electrical clips, Delta Circuit Works bases, emery cloths, nails, small paper clips, rubber rings, 15-centimeter plastic insulated wire pieces, wire cutters, and a roll of enamel-coated wire. You will also need to provide metric rulers. To prepare this activity, make one copy of Activity Sheet 6, Parts A through C for each student. Cut one 2.25 meter length of enamel-coated wire for each team of 4. About 1 centimeter of the enamel coating should be removed from each end by lightly sanding the ends with a piece of emery cloth. Each team will need a nail, 2 rubber rings, 25 paper clips, a piece of emery cloth, 3 D-cell batteries, 6 electrical clips, a circuit works base, 2 15-centimeter pieces of plastic insulated wire with stripped ends, 1 2.25 meter length of enamel-coated wire, and a metric ruler. To begin the activity, distribute a copy of Activity Sheet 6, Parts A, B, and C to each student. Remind them that they made a temporary magnet by placing magnets on either side of a nail and that they created a magnetic field by connecting a wire from one terminal of a battery to another. Inform students that they will now create another type of temporary magnet using the nail in combination with the electrical circuit. This magnet is called an electromagnet because its magnetic field is produced by electricity. Distribute the materials to each team and review the directions in Step 1 to build an electromagnet. First, push one end of the enamel-coated wire through a rubber ring. Then, push the tip of the nail through the rubber ring. Slide the ring toward the head of the nail and pull about 25 centimeters of wire from under the ring. Wrap 10 turns of wire neatly around the shank of the nail. Be careful not to overlap the wires. Add a second rubber ring to the long end of the wire and slide the ring over the tip of the nail to hold the wraps on, about 2 centimeters from the tip of the nail. Connect each end of the wire to a battery. Try to pick up paper clips with your electromagnet. Then ask students, how were you able to tell that the nail was magnetized? Students should mention that the end of the magnetized nail attracted paper clips. Next, have students complete Steps 2 and 3 on Part A of the activity sheet and record their data on Parts B and C of the activity sheet. If they have difficulty graphing their data, help them number both axes of each graph and then show them how to graph the first set of data points on their chart. In Step 2, students test the number of paper clips they can pick up as they increase the number of coils wrapped around the nail. In Step 3, students test the number of paper clips they can pick up as they increase the number of batteries. As needed, supervise the teams as they add 2 more batteries to the circuit works base. Use 2 electrical clips to secure each battery to the base, making sure the terminals line up in the same direction. Connect the batteries in a series with the 15-centimeter insulated wires. Next, ask students, using just the tip of the nail, how many paper clips can you pick up with your electromagnet? The number of paper clips that can be picked up will vary depending on the number of batteries in the circuit and the number of coils on the nail. Then ask students, does adding paper clips to one end of the nail affect the other end of the nail? They will observe that the magnetic strength is the same at either end of the nail, regardless of the number of paper clips already attached. Ask students, if the nail is removed from the coil, will the coil alone pick up paper clips? They should understand that the nail is an essential part of the electromagnet. Then ask students, what would happen to the strength of the electromagnet if the coils of wire were spread out more? They should understand that nothing would happen as long as the number of coils on the nail remained the same. Finally, ask students, what factors affect the strength of an electromagnet? They should understand by now that the more turns of wire wrapped around the nail, the stronger the electromagnet is, and the greater the number of batteries attached to the circuit, the stronger the electromagnet is. To conclude the activity, Save the nails wrapped with 100 turns of wire for use in activities 7 and 8. The circuits should be disconnected and the materials removed from the circuit workspaces. For science background, reinforcement activities, curriculum connections, and information about the Delta Science Reader, please consult your DSM Teacher's Guide.